Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Yesterday. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms. Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Yesterday. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms.
All right. Good evening, everyone. Good evening, good evening, good evening. Can you all hear me? Please let me know that everyone can hear and see me. Yes, yes. All right. Thank you. All right. Thank you very much. Good evening. How was day? How was your day? Hope it was nothing like my own. Uh, my day is not something I think I wish for anybody to go through. My day has been back to back, back to back. So I hope that your day was smooth, was fine, was easy, not tough and difficult. Okay, all right, okay, all right. So let's just get into today's class. Oh, Debbie, so sorry that your day was stressful. Sorry, take a hug from here. Okay, all right. So let's get started. Let's get started. Um, Today I'm sure we can all see my screen as well. I'm sure we can all see my screen. If you can see my screen, kindly confirm what you're seeing on my screen so that I can be sure that everybody is seeing my screen. What's our topic for today? So if we can see my screen, kindly tell me what you're seeing on my screen. Thank you. Thank you for Insola. All right. Okay, so that's confirmation that everyone can see my screen. Okay. So we're going to be doing some interesting stuffs today. I think we've done it before, but today we're going to be going into details um, of what the AWS EC2 instance is, right? Or the AWS EC2 service is, right? And before I go forward, I want to believe that all of us have taken our quiz. I can't ask how many people have taken it because I can't take a count here, but I want to believe everyone has taken their quiz. Please, I'm sure it would have closed by now already. It was to close by 6 p.m. Please note that that's taking of that quiz is like your attendance or your qualification to getting the AWS account open for you. The environment will be using throughout this training, which start creating by tomorrow. So look out for invitation mails in your inbox to open your AWS account. All right, so without further ado, let's get started. Today, there might be quite a number of questions, so please just as I'm going on, if I can take your questions during the class, just wait till the end, and during the question and answer session, would address all our questions. Okay, so let's get into it. So, AWS EC2 instance, we'll be looking at how to launch, how to configure, and managing EC2 instances, right? So, general overview, right? What's EC2 instance? It's I think we've said it before. Myself and Mr. Moses has mentioned this quite a number of times that EC2 instance is basically an acronym for Amazon Elastic Compute Cloud. So when you hear Amazon EC2, it simply stands for Elastic Compute Cloud, right? And it's what provides a resizable computer or compute capacity in the cloud and allows you to run your virtual servers, right? So the virtual servers are what you know as or what is known as the EC2 instance, right? So when we say something like resources and service, when we're asking what's the difference between a resource and what's the difference between a service, right? So EC2 is the service, right? While an instance is a resource in the service, is something that you create within that service. There are other resources that you create that we'll get to find out, or that makes part of the EC2 that are also resources that we'll get to find out today as we go in, right? And what's the reason for using the EC2, right? Number one is scalability. So if you're trying to pitch to a customer to say, oh, I want you to use EC2. I'm prescribing that you use EC2 for your application or for your website to host it. What's the benefit of it? Basically, scalability. They can scale depending on the size, right? They can reduce it depending on their need, they can increase it depending on their need, and also it's flexible. So there are different type of workload that you can put on the EC2 instance. It's not very, very rigid, so to say, right? And then there's cost effectiveness. We're going to look into a bit of the payments method for EC2 instance today. So just be on the lookout. So this is just a basic overview. So let's now go deeper. Right. So what's an EC2 instance? I said EC2 instance is part of the resources of an EC2, right? It's majorly the thing that is most spoken about. Um, Give me 1 minute. I thought I had muted my notification, but I seem to be hearing it and it's quite loud. Please give me 1 minute. Okay. All right, I think that should be better now so that nothing is getting in our way. So I was saying that the virtual EC2 instance is a virtual server, right? One of the things that I think the admin would have done today, if you check your LMS, or if not today, maybe by tomorrow morning, is we've made a glossary, so to say, where you find the definition of terms that you'll be coming across. So in that glossary, you'll find the definition of what a server is. So for those of us that were not probably in the class at the beginning when we talked about a server, right? And I think I'm also going to put a link to where you can read more on what a server is so you can get a broader understanding. So an EC2 instance is basically a virtual server. It's like a server is basically like a computer system. It's like your CPU. It provides services to a client. Clients can be your screen, your monitor, right? Your phone, all of those things. So it provides different services. It can be the storage service, it can be hosting your application. Some of us have our applications running on our systems, right? So that's what a server is, right? And it can run run different operating system. When you check that glossary, you also get to find out what operating systems are, what they mean, right? So there are different type of operating systems. There's a Linux, there's Windows, there's Ubuntu, there's Mac OS, and the likes, right? So the common one, the ones you most likely come across a lot working with clients will most likely be the Linux and Windows. I really come across people say, "Oh, I want to host my application and it's using a Mac OS." Very, very few occasions, especially here in Nigeria, people are most likely tilted towards the Linux and Windows operating system. Then, what can you use it for? Different things. You can use it to host your website. You can use it for data processing. You can use it to run your applications and so many other things. Now, what's the components of um, EC2 instances, right? One of there are four major components. One is the AMI, Amazon Machine Image. So we'll go into deeper meaning of all of these components as we go in tonight. So we have the AMI, that's Machine Image, and it's basically a pre-configured template that you use to launch your instance. You have the instance type, you have the security group, and you have the key pair. So let's go into what all of those things mean. Now, the AMI is an acronym for Amazon Machine Image, right? So it's basically the basis of an instance. It is what is carrying the OS, the application server, is what is carrying all the information, the software information, so to say, of the instance. So that's if I go to say, oh, I want to launch an instance now, this instance I want to launch is going to be a Windows instance, right? Not a Linux. It's going to be a Windows instance. It's going to be a by 86 architecture and all of those things that you don't need to worry your pretty head about, because whoever is asking you to create that will probably give you the specification and configuration of what they need, right? So you don't necessarily have to know what the customer wants. They tell you exactly what they need, and then your job is to go and look for that AMI that suits their need, right? So the AMI is like the basis. It's it's what they call the virtual appliance, right, of the EC2. And it's it's not something you can bypass. Is a compulsory element when you're trying to launch an instance. In short, it's the first thing you're going to have to choose when you are launching an instance, because like I said, it's what is carrying the operating system. So what's the component of an AMI? On the right hand side, you'll see I've listed them. You have the operating system. That's where you choose whether it is a Windows, a Linux, Ubuntu, Red Hat, whatever the OS that you want to use. Also, is what is going to be carrying the application server, right? Say, for example, now you have created an application, right, and you've deployed that application on the EC2 instance. The configuration of that, the framework of that application, the things, the way it's going to work, the framework, the workflow, all of those things will be saved in the AMI, will be saved in the Amazon machine image, right? Any application that you host on that EC2 instance will be saved in that um what are they calling it now? The AMI. So I'm trying to a typical example is like our laptop, right? So the AMI of your laptop is what is going to be carrying your operating system. Let's say for those of us using Windows, right? Operating system for our laptop is Windows, right? You put an application on that system. If for any reason this crashes, this laptop crashes, it's expected that if I take that I should be able to get everything that are native to the system, everything that are native to the system. So if I maybe took a snapshot of this AMI, right, I should be able to, and I put it in another pangolo, another container of a laptop, I should be able to see everything that was on that my former system on this system, right? So the AMI is what takes the, or is carrying the operating system, the application server, the application, all your configuration settings, your libraries. For those that's code, or you are a developer, you know what I mean by libraries. Let's say you are using Python, for example. Your libraries can be your pandas, your scikit-learn, and all of those things. Please, if you don't code, don't be scared. Do not be scared. You might not really need these parts, right? So, but these are things I needed to mention. So that's one of the first component of an EC2 instance. The second one, sorry, before I go to the second one, there are different types of AMI, right? There's like when you go to this evening when we're going to be doing the demo, when you go to the AWS page where you want to launch an instance, you'll find that there are different type of AMI. There's one that is provided by AWS, like the Linux one, and there are some Windows OS that are provided by AWS. There's those that are provided by the community. So community is, there's an AWS community. So I created this particular AMI. I put it up there so people can use it as well. So you don't have to go and create your own from scratch. You just have to look at the components of the AMI that I created and see if it fits what you need the AMI for. If it does, you can use it, right? Of course. Marketplace is also like a company and another organization, right? They're like third party vendors. That's marketplace is basically for third party vendors. People that say, oh, I developed this particular software. You can also use my software in your AWS environment, right? So you can find AMIs there on the marketplace and you purchase. And then the last one is the custom AMI. Custom AMI is the one that you made by yourself. Let's say, for example, you launched an EC2 instance, you've put some things on it, maybe you use it to host a particular um, website, right? Or maybe an ERP solution, right? You put it on that EC2 instance. Now, I want to go and create another EC2 instance. Instead of me to go and start selecting from beginning, and then when I now launch that instance, I'll now start uploading all over again. I can just take a snapshot of that particular AMI. So that becomes my own custom. I created the AMI. So because those things are the things, all the information, the configuration that are on it are going to be the things that I had set up before, right? So I'll just save it and then I can use it. Or maybe you have a particular configuration that is needed, that they said specifically in your company you have to use this. You've checked AWS on, it's not there. You've checked the community on, it's not there. You've checked marketplace, it's not there. So you have to create your own. You can do that yourself as well. You can create your own custom AMI and name it whatever it is that you choose to name it. All right, so moving on. So the second component of the EC2 instance is what the instance type. So there are different instance type, and what instance type is what is going to determine the hardware of of the computer that your instance will be sitting on, or that will be used for the instance. Now, what do I mean? I said the AMI is what is carrying the software aspect, right? Your OS and all of those things. Now, the instance type is what will determine the hardware. So hardware will be okay. So this person wants to launch their instance in US region, right? So in this US region, what basically AWS is going to do is they'll go to US data set, the region or the data center that is US, which is that region, right? They will go to that data center. They'll now check, okay, which type of instance did this person choose? Is it general purpose? We're going to explain what general purpose compute and all of those things mean. If it's general purpose, for example, which is okay, this person wants two vCPU of 2 vCPU, 4 gig RAM memory. That's the hardware that this person needs. So they will make sure that your instance is staying on that particular hardware. So it is what determines, or what it speaks to your computing power, your RAM, your yes, basically those two things are the major things that they speak to, right? So the ratio of the computing power, which is known as the vCPU, and the RAM. That RAM is like the internal storage. Like when you buy a phone, there's a storage that comes with your phone, and then you can now also have an extra memory card. So memory card is like your hard disk. In AWS, that's not like your EBS, right? Elastic Block Store. That's like your hard disk to your instance. So the instance type is what determines the RAM, which like your in-house storage of your instance, not the hard disk, right? And then also the computing power, right, which is known as the vCPU, that's virtual computing unit. So there are majorly four types, but when we go in, there are more than four. There are about six now, but these are it usually revolves around this four. So we have the general purpose, we have the compute optimized, we have the memory optimized, and the storage optimized. Now, the general purpose instance type, right? It provides a balance between your compute, your memory, and networking resources, right? So it makes it suitable for a wide range of purpose. When you say something is general purpose, bobo niche, right? So it's provides that balance, so to give you balance of compute, balance of memory. So you can find something like a 2 vCPU, 2 gig RAM. You can find something like a 4 vCPU, 4 gig RAM, right? Those kind of things. So it gives you a balanced ratio of what you need, right? Um, then they are also ideal for applications that require a balance between performance and cost without the need for high levels of any particular resource. So this kind of instance types, again, the things that would inform your decision on what type of instance you are going to choose is the kind of workload you want to put on that instance, the type of applications you want to run on that instance. That's what will determine the kind of instance or the type of instance that you are going to be selecting for your workload, because all of them have their strengths and their weaknesses, right? So some of the examples of the general purpose is T2 and M5. They have quite a lot. There's also T3, right? They are called families. So this, when you see this, they are called family. There's T2 family, there's M5 family, there's T3 family. They are called instance family. In the slide, sorry, excuse me, it is uploaded to LMS, you are going to find a link to an external resource that will take you to where you can get all of this instance family, their instance type, what they are and what they do. So what are the use cases for general purpose web servers? You just want to upload a simple website, There's no need to go and be using a compute optimized or storage optimized. You just use the general purpose. Then for small databases, maybe you're just in a database for your church that people are just about 50 people, right? You can just use this one. For development and test environment, say for example, you're trying to develop an application and you just want to test run it, it's not yet going live, it's not yet at production level, right? You can use a general purpose one. It will give you a balance of the resources and also cost. Sorry, excuse me. I'm so sorry. Today I'm quite I'm quite tired this evening. So it gives you a balance of cost as well. So they are not usually that expensive compared to the other ones. The other type is the compute optimized. Now, when you say compute optimized, it's majorly in plain language, right? Without reading from here, is saying that it's going to favor the vCPU more than the RAM, right? You know, I said that two things that the instance type basically focuses on is your vCPU, that's your computing power, and the memory, that the in local memory, right? That's your RAM. So for compute optimized, those instance types are usually they favor compute power. So you have something like a 4 vCPU 2 gig RAM. You know, unlike the general purpose where you can have a 2 vCPU 2 gig RAM, this one you probably find like a 4 vCPU, it's 2, or rather 4 vCPU 2 gig RAM, or 8 vCPU 4 gig RAM, right? So they are not very they are not particular about the memory. Those instance types are not really focused on memory. They are much more focused on you need, and the vCPU is what controls the output and the inputs, like the processing power, how fast those things will be moving. So you need to process something, how fast will it be going, right? On your application, it's the vCPU that controls that. So the more vCPU you have, the more work you are able to do on your system. Say for example, if you're using a laptop, they'll tell you that, oh, this particular laptop cannot carry something, the power is too small. What they're basically telling you is that the computing power of that laptop is small. It cannot handle the work that you want it to do on your system. For people that are like data scientists now, there are some machine learning stuff that you cannot do on your system, or on some systems. In short, there are some that you cannot even do on a system at all. Your system will crash. I remember when I was trying to do one for my final assessment when I was doing my internship then for data science, and we're supposed to build one um, recommender for a building for where you can put your businesses, right? For small scale retail businesses. I could not use my system. The one I was using then was crashing because the computing power of that system is not so much. So like I said before, right, EC2 instances are like your computer, just that they are virtual, they're in the cloud. So an instance type that is compute optimized is going to give you much more compute power than memory. To give you much more compute power than memory. An example of those compute optimized instances are the C5 family, the C6G family, and so on. There are so much more. Please do well to check through the additional resources that will be added, because we can't cover everything here. So if you read through the resources and you have other questions, you can always drop it on the Telegram channel, right? Okay, so use cases, of course, high performance computing, gaming servers, batch processing. Those are the kind of workloads that usually require compute optimized instance types. Now we also have the memory optimized instance type. Now is basically the opposite of the compute optimized, right? So this one is much more favorable to the memory, your in-house memory, right? Your local memory. So it says that they are designed for workloads that require a large amount of memory relative to CPU performance. Relative to CPU performance. And it says these instances are ideal for application that processes large data sets in memory. Now, let's say, for example, you have an application, and that application is an application that will be taking in a lot of data, right? At the same time. Say, for example, now I'm trying to look for the perfect example that we can use. if I develop an application where I say I need this application to be processing the number of students in data of students in Nigeria, so which means that per second, right, this application is going to be receiving data sets of students in Nigeria per minute, and they might even be updating, because the students can say, oh, I've been promoted from SS1 to SS2, is updating it. So it's going to need a large space to put all those data. It's going to need a large memory to be able to process all those data that you are giving to it, not just to store them, right? Not to store the data now, to process it. So I say, okay, as this data is coming in, process it, give me what they call it, like a visualization, where I do an analysis of it, right? I'm going to need a memory optimized instance type. I'll need a memory optimized instance type, because the thing I want to do is much more memory demanding than compute power demanding. It's going to take much more memory than, so you'll find out that you'll see something like a 4 vCPU 8 gig RAM, right? I didn't say 4 vCPU 8 gig RAM, those kind of things, right? So example of those are the R5 family, the X1A family, and the use cases. You have your databases. So you can have your databases on-prem. So maybe you want to move it to the cloud and you don't want to move it to a managed database. When we get to databases, you understand what I mean by managed database. So managed database is basically AWS is going to be managing the database for you. You don't want to move it there. You want to have a bit of flexibility on your own to be able to run it. You can put that database on the EC2 instance. Now, a memory optimized instance type can be used for that kind of a database. Then also in-memory caches. All right, so now this is where it gets interesting. There's now the storage optimized instance type. I know the question will come now, what's now the difference between storage optimized and memory optimized? Are they not supposed to be the same thing? Intentionally, even though I'd added it to the slide before, but intentionally I've removed it because it's going to be our assignment, or parts of our assignment for this week. Right. So I want us to begin to go and read up and learn things on our own. Right. So general overview, a storage optimized instance is designed for workload that require a sequential read and write access. So this is a bit of technical jargon, right? That's not a lot of us are going to be privy to, and I don't want us to get scared, right? So basically, what read and write means is when you are reading a data, is you are access. Say if I give you an access to my database now, right? You go and check it. Maybe you want to see how many customers does give me the name of a company, does Incubator, or how many students does Incubator have right at the moment. Now Incubator already has a database where that information is sitting, right? So me, I want to find out how many students does Incubator have at the moment. So I write a SQL query to say, give me the total number of students in Incubator at the moment. What I'm doing at that moment is I'm reading the database. I'm reading the database. Now, writing is you are adding to it, you are adding to the database. So, for example, they've just added a new set of students, the cloud computing students, the number of students that what are they calling it, Incubator now has, right? Which means that somebody at the back end in Incubator, working with Incubator, we have to go and update the database with those students' details, right? We go and update that database with the students' information and all of those things. Now that is writing. Writing is you are updating, you are adding something to it, or you are removing something to it. Reading is you are just getting information from what is already there. Now there are some workloads that will require reading and writing at almost the same time. Somebody is trying to get information from that database, somebody is updating the database. So there's a lot of things that is happening at the same time on that database, right? As the database is trying to give the person that needs information, right? Somebody that is trying to update it is also has to get it ready for the person that wants to update it with information to also update it with information. And all of those things are happening on the local storage, not even in the hard disk, or something is happening on the local storage of that instance. Then you will need a storage optimized not just a memory optimized. Memory optimized will no longer be enough. You're going to need a storage optimized because there are a lot of things that are going on. The problem now is not just for me to just save these things, right? It's because I need to be accessing this data. I need to read them. I need to write them. Somebody else needs to get analysis from them. A lot of things are happening at the same time, right? So, and all of those things are happening with the data. So you need that storage optimized instances. So you find out the examples of those kind of instances are the I3 family and DD2 family, right? So what are the use cases? Transactional databases. Like I said, you find companies like your financial institution, for example, banks. Banks databases are probably one of the most complex, right? Because they have customer data, they have employee data, they have CBN data, they have all of those things that are coming in as it is. Somebody that is sitting in branch A is trying to get this customer, is trying to see this person that is attending to what's this customer's data. So he's querying the database, right? Although he might not even know because he's just in the front end of things. He's just clicking a button and he's getting it. But in the back end, something is telling the database, okay, Bosse has requested for the picture of this customer that is standing in front of her with this account number. So he has to send a message to that database, give me this data. At the same time, somebody is probably just opening an account and they are updating the database with that person's details. So a lot of things, transactional databases are, if you have a customer that is, maybe a bank says, oh, I want to put my database or something on the cloud, but I don't want a managed database. You have to, recommend to them a storage optimized instance type if they are putting it on the EC2 instance. Also, is things that need real-time analytics. You want to be analyzing that data on the go. It's not like, oh, you come back tomorrow and come and analyze the data, or next tomorrow come and analyze the data that was already stored. As the data is entering in, like when COVID happened, for example, you see that they were updating the data. Like it's always running. You always see, okay, number of persons infected, number of persons that have died in which part of the country or in which part of the world in Nigeria. Those kind of things they need storage because the application that is going to be running it is getting data from every part of the world. People are requesting for data to say, okay, I want to know how many people have died in Nigeria. I want to know how many people have died there. Meanwhile, there are also some people at the back end also updating that database to make sure that it is correct. So for real-time analytics too, it is usually recommended that you use a storage optimized instance type. Now, there's something called accelerated computing. And this is what I added as the JARA. There's also another one, I think that's a HPC, right? High performance computing. You also go and read up on that. That's also going to be part of your assignment, right? So accelerated computing is, we talked about the compute optimized earlier on. So accelerated computing is a much more bigger scale. What you need now is not just fine computing, like give me compute over memory. You need massive compute power. Say, for example, an application of video games, things that need to process video and images. If you have you noticed that sometimes when your network is not so good and you're on YouTube, the video is playing, oh, but the picture is not very, very clear, it's very quite blurry, right? The reason why is because it takes more to process video and images than it takes to process just text, right? Text is not going to consume so much, but when you're doing video and image processing or generation, it takes more computing power. So those kind of things require accelerate, or is recommended that you use accelerated computing, or you're doing a machine learning training. Machine learning, well, depending on the type, things like your chat GPT, the system that is going to be running on the application is going to be running on, where it's going to be sitting, is going to be a very, very sure, maybe not an accelerated one, maybe a high performance computing one, a very high end, something that can manage all that it needs, the compute power that it needs, because it's going to be very, very great. So they are used for all this number calculation, floating point number calculations. If you don't know what floating point number calculation is, just Google it, right? Graphics processing, data pattern matching, things that are much more efficient than just software that is running on a general purpose, right? CPU, then you can use this type of instance for it. Moving on, I'm sure a lot of us are probably confused tonight. Let me see. Are we confused yet? Are we confused yet before I go on? Okay, so famous said is not clear. So just note all the parts that is not clear, right? And then I'll get back to it. Just note them down in the question, in your questions, right? Rather, and then we'll get back to it. Then during the demo, you probably get to see all of these things more, and then you probably understand better. And also, oh, someone said I'm too fast. Oh, I'm so sorry. Okay, I'm going to slow down going forward. Also, something I want to put out there is don't expect to get all of this in one night. The truth is, I think I said it from the beginning, cloud is a lot, it's massive, right? Some of these things will be settling in later on. You'll not be like, oh, so this was what she was saying, oh, this is what she meant, right? So don't be hard on yourself. If you don't get it now, you can always go back to it. You can always chat me up. You can always chat Mr. Moses up, and we'll always explain to you. Anyway, that's if I'm not able to give you or answer all your questions here on the live call, right? So please, no pressure at all. This is not something that you learn in 1 week or in 2 weeks, right? Okay, so moving on. Another aspect of, or the another component of the EC2 instance, right, is the security group and key pair. So security groups is like your virtual firewall, right? Is what determines what goes into your EC2 instance and what traffic goes out of your EC2 instance. So the way it works is, and I think I forgot to add that image. We're going to see that in an EC2 instance, or the security of the AWS environment, there is security of the subnet itself. So subnet is where you put your EC2 instance. When you create, you choose the region you want your instance to be in. When you choose that region, you're going to choose, okay, which availability zone. So in your VPC generally is created in the region. Your subnets are created in the availability zone. So your instance or whatever it is you want to create are created inside the subnet. Now, what controls access to the subnet is called NACL. It's called NACLs, right? That's network access control lists. Yes, network access control list. That's what controls access to the subnet. So now, I wish I had a drawing pad to be able to show you. So just imagine you have a box, right? In this box is your subnet, right? Now, inside this particular box, there's another box, and that box is your instance. So if traffic is coming from maybe from the internet or from somewhere else, somebody is trying to access your instance. First of all, it's going to be met by the NACLs, that's the network access control list, which is what is guarding the subnet itself. So what that one is going to do is, I think Mr. Moses explained that to us last week, right? What that one is going to be, they're like your security guard. Is going to check, okay, does this person have this person on the list of those that are allowed to enter this subnet? Was this person invited? Did this person have access card? Like when you go for your wedding, right? Before you can enter into the wedding or the wedding venue, right? The security at the gates will check, where's your IV? They'll check your IV. Or maybe they did not give you IV. They have been given a list of people that they invited. They'll say, okay, what's your name? You give them your name, they'll check their list. Okay, your name is there. Enter. Oh, sorry, your name is not there. Get out. Right? That's what the NACL does. So your wedding venue is like your subnet. NACL is what controls access into that wedding venue. Now, inside the wedding venue, right, you now have different things you can put there, right? You have the catering area, you have where the bride and the groom is going to sit, you have different tables that has been set in place, right? So Now, for you to be able to access some of those areas being like your instance that you have launched, maybe I'm the one that created the catering area. I have put a rule in that catering area. So the catering area is like my EC2 instance that I set up. I have put a rule in that catering area, and I have said that the only people that are allowed to come to this catering area is the mother of the groom and the mother of the bride. Those are the only people that are allowed to come to this um, catering area, right? Which is my instance in this case. And I have said the only people that are allowed to carry food away from these catering areas are the ushers, right? It's only the ushers that are allowed to carry food away from this catering area, which is my instance. Now, remember that you have gotten access into the subnet, which is the wedding venue. So that is fine. But your access only allows you to enter into the subnet. It does not give you access to the catering area, which is your instance, right? So if you now go to the catering area, you're not the mother of the groom. The security group will now check. Are you the mother of the groom? No. Are you the mother of the bride? No. Sorry, you cannot come close to this catering area. It will bounce you. You won't be able to get access to the catering area, right? So that is what is known as the inbound rule. So inbound rule is what controls who is coming in or what is allowed to come into that instance. So let's say, for example, I want to access your application from the internet, right, from Nigeria. I don't know how many people have experienced you are trying to get to a website, and then that website they will tell you that, oh, sorry, you cannot add this particular what are they calling it? This particular IP address is blocked because it's coming from Nigeria, right? How many people have experienced that before? You try to access a website and then they tell you that you cannot access it because Nigeria people are not giving access to that website. I've experienced it before. Is there any other person that has ever experienced it? You're just trying, somebody sent you a link, access this link, and then you just click. Thank you very much, Debbie. So, what's happening on that end is that there is a rule. The person that created that website has put a security group rule or a firewall rule to say, I only want people that have their IP address. You know, IP address is like your house address, but on the internet, right? I only want people that have IP address that is coming from America to be able to access this particular website. So, of course, you have access to the website, right? You've gotten access to the subnet, isn't it? But you cannot access that particular thing that was put in that subnet. Why? Because your security group is blocking you. So that's an inbound rule. So an inbound rule is what you set to prevent or to allow. So it's either allows or denies. It will either allow you to either say, oh, I'm allowing this particular set of people to come in, or I am denying this particular set of people to come in. Hope that has gotten to this point. Now, outbound rule is now the example of the one I said about what are they calling it now? Um the ushers, right? When I said the only people that can carry food away from the catering area are the ushers, that's an outbound rule. So it means I'm saying the only people that have the right to leave the catering system, right, or the catering area are the ushers. So I'm saying I've created this application. Now, my application wants to, maybe it needs to update itself and it needs to communicate to the internet to be able to get what it needs to update itself, right? But I have already set a rule to say this application, no, you cannot go past the subnet. You cannot access the website or the internet. No matter what that thing does, it will not be able to access the internet because there's an outbound rule that has limited it to say you cannot go out except that rule is what is removed. So that's what the security group does. Security group is what allows or denies access to your instance. To your instance. Hope that is clear so far. I'm trying to take my time to explain this part because I've been told I was fast before. Is that clear so far? Do you understand the security groups? Okay. All right. Thank you very much, Debbie. All right. So the last component that we're going to be talking about, right, is the key pairs. Yes, please don't worry. You blend in. I must tell you, it didn't take me. It's not fast. It's not something I do overnight. I think I already gave an example of myself when I first wrote the cloud practitioner exam. Believe me, you half of what I was putting down, I just read it. Right. You know when you are reading and pouring, you're reading and pouring, you don't really have an understanding. I didn't really have an understanding of it. Right. But as time went on and I started experiencing this thing, working with these things, it started becoming clear that, oh, so this was what that thing I read. Oh, so this is how it actually works. So give yourself grace. That's what I'm going to say a lot this night. Give yourself grace. Don't be hard on yourself. Don't say, hey, you know, don't me, I don't understand it. Please, these things are going to be confusing, especially if you're not coming from a computer science background. Some of these things are going to be confusing to you at the beginning. All right, so the last component of EC2 instance we're going to be talking about is the key pair, right? So key pair is not a security rule, it's not a rule that you set, but is also something that's kind of secures your instance. So let's say, for example, right, I'm launching my instance, which is what we're going to see. We're going to see it when we get to the demo part. I want to launch my instance, right? At that point, I'm going to download a particular key pair. That key pair is only me that will have access to it. It will be downloaded to my system, right? I'm the only one that is going to have access to that key pair. So anytime I want to go to my instance, maybe not from what are they calling it? I don't want to go through the management console, right? Maybe I want to access that instance from a CLI, right? A command prompt or something. I want to do that. What's going to happen is it's going to request from me, where is your key pair? Now, please note, it is not a compulsory thing, but it is usually advised that you actually do what you use key pairs when you're creating your instances. Why? Because somebody else can be able to hack into your account, right? And if you don't put a key pair there, remember the key pair I said is something that is personal to you. You'll be the only one to have it, except you share it with somebody else, right? So because you're the only one that have access to it, even if the person has been able to hack your account, the person will not be able to hack into your instance, right? Because by the time it wants to log into that instance, it's going to ask it for what? For the key pair, and the person will not have it. So it's usually advisable that you have it. So it's something that you generate when you're launching the instance. It is a private key, like I said. Most times you can do without launching for Linux, but for Windows instances, even though you can do without using it or without generating a key pair when you want to launch your instance, but for Windows instance, I've noticed from experience, you will not be able to sign into that instance without your key pair. Even if you did not generate one, it will tell you that it's requesting for the key pair that you have. So that key pair is like an encryption for a particular passcode. We're going to do a demo of it. So we're going to be doing demo after the attendance break, which is in like 5 minutes. So please just take note of all of these things. When we're doing the demo, it should be clearer to us. We'll do a practical example as much as I can cover tonight. Okay, so yes, since we're going to be doing demo just after the attendance, let's just cover everything in the slide so that we'll know that after the attendance, we're going straight into demo. So pricing models. I know we've said a lot about pay as you go, pay as you go. That's one of the good thing about the cloud. But that's not the only way of paying for things in the cloud. Of course, it's always your first option. That is going to always be your first option. But for your EC2 instances, there are more than one payment option. There's the on-demand instance, right? So all of this instance, this is not an instance type of compute optimized or memory optimized that was confusing us. These ones are based on types of instances based on their payment type, right? So at the point of launching your instance, you can choose either an on-demand instance, reserved instance, spot instances, or savings plan. So what is on demand? On demand is the one we'll be hearing about. You pay by the second or by the hour. AWS charges you for instances by the hour actually. So you pay by the hour. So immediately you launch your instance and it starts showing running, your money starts counting. So for every time that your instance is running on AWS, right, it is that you are being billed per hour for when it is up. Now, if you don't need that instance again, or maybe you feel like, okay, I don't need it for now, I'll use it later, you can stop that instance. Immediately you stop the instance, your money will stop running. So that's what you mean by is a pay as you go. It's on demand. It's whenever you need it, you pay for it. So whenever you are using the instance is when you pay for the instance. Whenever you are not using it, maybe you have stopped that instance or you've terminated that instance, you are no longer billed for it. Now, what are the use cases? It is usually used for short term, right? Because the on-demand pricing model is the most expensive pricing model, is the most expensive one, right? So you're not usually advised to use it for a long-term stuff like 1 year, 3 years. No, don't be on demand for that long. We'll go to the ones you can use. Then for unpredictable workloads, what does that mean? I just started this application. I just created this application. I've not tried it before. I don't know how people are going to receive it. So I cannot tell you whether, oh, it's on Fridays that people used to be plenty on the application. Say, for example, Jumia, right? Jumia website on every day of the year is probably normal traffic. Very few people will go buy something. But whenever they announce that, oh, we're having a Black Friday, on that Black Friday, what will happen? They are going to have serious influx of customers, right? That is going to affect their website or will need more computing power to process, right? Now, that's I have now sat down, I've looked at that application and I've noticed that, oh, it's only every Black Friday that we used to have a lot of people, right? That's because I've watched it over a period of time. That's why I can come to that conclusion. But I am just starting this particular application. I don't have any data on it to go and analyze to say, oh, it's only on Fridays that people used to use it well. Oh, it's only Mondays that people used to use it well. Oh, it's every day of the week that people used to use it well. So what will happen in that case, because I cannot predict, I will be on demand. So I'll be on demand for a short while, maybe for like 2 months, 3 months, see what my utilization is like, right? So that after that 3 months, I can now go and analyze what is my utilization and then be able to decide that, oh, okay, maybe I need to scale down or scale up, or maybe this is perfect for me, right? So moving to the next type of pricing model is the reserved instance. So reserved instance is you are committing to a 1 year or a 3 year period, and what AWS gives you in return is what? A discount. You can get a discount to up to as much as 62% discount compared to, let's say, if you are paying $1 for an on-demand instance that you are paying per hour. If you are on a reserved instance, right, you're probably going to be paying about 0.42 dollars, right? So that's about 62% or 68% discount on compared to the on-demand price. Now, use case for this one is you already know the workload. Like that example of Jumia that I said, right? Jumia already knows that, oh, this is how our workload used to be. We have this much people, right? Maybe just 50 people visiting our site every single time in the year. So I can just purchase a small, maybe general purpose EC2 instance, right? For that, and I will lock it down for 1 year. Now, what that means is that for that 1 year, whether or not your EC2 instance is running, you are going to pay. Whether or not it is running, you are paying because you have reserved it. So when you have reserved an instance, what AWS does is that on the back end, they will go to the data center and say, this particular hardware or this particular resource, we are keeping it for this person. This person has paid for it for 1 year. It's like you are renting a house. If you pay for 1 year, everything that is there, if you like, don't sleep inside the house. Nothing will concern your landlord again. All the pays for you. you have already paid for the 1 year or you have already paid for the 3 years. So that's like what the reserved instance is like. So reserved instance is usually recommended when you are guaranteed of what your usage would be like, because once you reserve it, you cannot change it until that period that you reserve it for elapse. But it's beneficial to you, especially when you know what your usage is like, so that you can always get the discount. Spot instance is like, so Jumia has done reserved instance for small instance type, right? Because they don't used to have plenty customers every day of the year. But on that Black Friday, they now have large influx. What happens? Instead of now going to go and add another reserved instance or get small and incur more cost, they will now do spot instance. Spot instance are instance that you just get for a short period, you just need it for a very short period of time, and they come at very, very low price. Why? Because they can also end, they can be stopped or terminated at any time, right? So I only need it for a particular task, for a very, just something that is not going to damage my kidney, right? For that short period, I can just use a spot instance and I'll get the discount. And once I'm done with what I want to use to do terminate shikena, everybody goes back. Savings plan is just like a reserved instance, right? But it's like you are committing to say, I'm going to be using a particular amount of my storage, maybe a 80% every time. I'm going to make sure I'm committing that I'm going to be using 80% of my uh, instance capacity every month. So if you commit to that, you have to be using it. If you don't use it, you're going to be charged for the parts or the period that you did not use, basically, or that you overused. So those are the pricing models. I think it's past 8 already. Can we go for a break? I think this is the only slide left before the demo. Admin, can we go for a break now? Can take our attendance break now. So once we come back, we'll wrap up with this and then we'll go to our demo straight away.
Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Yesterday. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms. Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Yesterday. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, It's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms. Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Aws Ec2. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms. Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Aws Ec2. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms. Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Aws Ec2. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms.
Okay, all right. Welcome back, everyone. I hope we've taken that 5 minutes break to just stretch our leg, feel the attendance, and rest a bit. All right, so let's get back into it because of our time. Please, if you're having any issues filling the attendance, please reach out to any of the admins. Sure, they'll be ready to assist us. Okay, we can come back to this later, right? Let's get into the demo so I don't confuse us a lot more. So we'll just finish up with this too when we're taking the questions. Okay, so let's just do our demo. Permit me to stop sharing the slide so I can share my other screen. I didn't confirm. Please, can we all hear me? Hope I'm not talking to myself. Hope I'm not talking to myself. Can we hear me? Can we hear me? All right. Thank you very much. Okay. Yes, don't worry. We'll go back on instance type if the time permits. If not, we'll just chat me up. Or I'm going to put a resource that can explain it better. Miracle. Is that Miracle? Or who asked about? Someone asked about the explaining the instance type. Okay, so let's get back to. Let's go to our demo now. Let me share my screen so I can share where that is. Stop screen. Okay. Right, please confirm when you can see my screen. Can we all see my screen now? Can you see the, let me know what you're seeing on my screen at the moment. Screen sim. All right, thank you very much. I'm happy and thank you very much. Okay, so I want to believe we are quite familiar with this interface. At least we've seen it before. Should not be strange to any of us. Okay, not bold. All right. So give me a minute. Let me zoom into this. Is this better now? I've zoomed in. Is that better? I've zoomed in now. Is it better? Okay, yes, better. Okay. All right. So I think we can move on. Happy, you want it to still be bigger than this? Okay, let's see if we can increase it just a bit more. It doesn't become okay. So it's at 150% now. So 150% is good for every one of us, I believe. Okay. All right. So let's roll. Let's get on with it. Okay. So myself want to create an EC2 instance. For Inshallah, I cannot be bigger than this, so it's already on 150. It's already on 150%. Maybe for those that are doing using the phone, it might be smaller. My apologies. Okay. Sorry, excuse me. Oh Jesus. All right, so let's get into it. So we're creating an EC2 instance, and I remember the last time I took us through the console, I said two things we're going to take note of, right? You can get your services from here either by clicking here and because I've gone to EC2 before, so you can see that it's part of my recently visited. But if not, you can always come here, go to compute, and then under compute you'll find EC2, or just easily come here and type EC2 under search on the search button, type EC2, and you'll find the EC2 here as well. Also, when you are creating your EC2 instance or any resources in AWS, always take note of this part. I remember I mentioned then that this is where you find the regions that your um resource will be sitting in. So currently I am in US East Ohio, right? That's where, so if I create an instance right now, it's going to be sitting in US East Ohio, but we can change that. So I can say, okay, I want it to be in Europe, Ireland, right? So I come here and I choose Europe, Ireland. So just hold on, it's going to reload and change that for me. So it has gone back to 100%. Let me increase it back to 150. Okay, so it's now 150 back. All right. Okay, so if you notice now, this is no longer Ohio, it's now on Ireland. That's where my, so it's highlighted now. So that's where, if I set up an EC2 instance, and that's where it's going to be sitting. So please always take note of this when you are creating any resource. All right, so we'll click on EC2, right, and it takes us to EC2's console itself, the dashboard. So I presently have one instance running because I had done a test, and I'll give us the reason why I did that test. Right, so EC2 instance, you can just click on instance here. Let me close this so that we can all see. So the one I created earlier on was sitting in Ohio. So that's one another thing. So depending on the region that you are at presently, it's going to be showing you resources that you launched in that particular region. So I had launched one in Ohio before, but I won't be able to see it now because I am presently on that Ireland region. So maybe before we end, I'll go back to Ohio and then I'll show you the instance that I launched there. So let's get to launching. You click on launch instance here. So when you click on launch instance, it comes here for you to launch instance. The first thing it's going to ask you for is to name your instance, right? It's going to name your instance. So that's what's going to be like an identifier apart from the ID. Something you can easily identify the instance by. So let's name this Lita test server. You don't have to put all this underscore. You can remove it. I can just can do Lita test server, depending on whatever it is that I'm comfortable with. So that's the first thing you put in when you are launching an instance, the name. Then remember I said one of the components that you choose or you select when you want to launch an instance, right, is the AMI. That's the Amazon Machine Image, which carries your operating system, the application server, and applications that you need to launch your instance. Right, so Come here, you can, if you have the name of the instance you're looking, the AMI you're looking for, you can come and search, right? But we don't have, and we want to use anyone. So you can check quick start here. Different places you can get quick start will give you like the common ones that are being used, or you can browse for more. So if I click on browse for more, it's going to bring me here. So remember that those types, the places I say you can get AMIs. If I do a custom AMI, if I click on my AMI, it's going to be under my AMI. If I go to marketplace, this is where I'm going to find third party, like the ones that other companies have already created. Like for example, I'm seeing this Wowza streaming engine. So this is an AMI that Wowza did, right? And it is a Linux AMI. You pay for it basically. So you can see people's review of this AMI. Somebody is just rated 2 stars. So you can decide on if you want to use it. You can see the amount that it costs and all of those things. So AMI is where you can also find. Then the community, these are the ones that I said the people can just come create, like I can create my own and then have it to the community and then tell you that, oh, you can use it. So AWS gave it. This one was provided by SUS, this one was provided by Red Hat. Different people, Ubuntu, different people, right? So different types. So just look for. But since we don't want stress for tonight, we can just go to quick start. Let's assume that what we want to run right now is on Amazon Linux, right? So just click on Amazon Linux. Sorry, excuse me. Sorry, please, I need to reduce my screen because I'm going to increase it back. I'm going to reduce it so I can see. Yeah, so this was what I was looking for, this button. So, ooh. So it has brought me here. Let me increase my screen back. Okay. All right. So I selected the Amazon Linux AMI, right? It's going to give me a description of that AMI that I chose. It's going to tell me that this AMI uses this is uses kernel 5.10 SSD volume type. Again, these are things that you don't need to bother your head about for now. In short, you might not even need to bother your head about it for a couple of years, because when you need to create or launch instances for customers or clients, they'll tell you what they need. They'll tell you the specification they need, and you can use those specifications to now come and search for AMI that tallies with their requirement or their specification, basically. So you don't necessarily have to go and start looking for what does kernel 5.10, except you want to develop an AMI yourself. Right, so it's telling me all the description of this AMI that I have selected. This is the AMI's ID. It's telling me where I chose it from, right? The date that it was published. Does it accept EBS? EBS is like the hard drive, right? So the hard disk that is going to be attached to it is EBS, right? So now the next thing we're going to choose or select the next component is the instance type. Now, under this instance type, you're not going to be seeing, oh, compute instance type, memory optimized instance type. You have to go and know those things by yourself. Say, for example, if you just come here, just come to Google and you type EC2, EC2 instance type, right? To bring you to different places. So you can come here and it's going to show you all the different type of instances, right? So if you think your customer needs a memory optimized and you don't know which family belongs to that memory optimized, you can only just come here, just click on memory optimized, and it tell you families, instance families, right? To tell you R8G, R7G. When you click on each of them, it will tell you what they are comprised of. right? So you can always check if that is what your client need or what you need for your application. So for today, we're going to be doing general purpose because, like I said in the slide, general purpose are used. You can use them for test environment, something that is small. You don't really need so much yet, right? So and out of these ones, there are also some that are available for free for a free tier that you can use that will not cost you. They won't charge you anything for that period of time that it is free. So let's come back here. So one of those family is, if you come back here, you see this T2. So the T2 family is under the general purpose instance type, right? So we'll come back to our instance that we're trying to launch, and you see another thing to notice, under the family there are different sizes. There's T2 micro, there's medium, there's small, there's large. If I click on this arrow now, it's going to show me all the instance type that are available, right? Because I increase my screen is why is that small or is that big. You can't really see it. Let's save and reduce it a bit. So you can, well, on your system is going to be smaller definitely, so you can see it well. So there's T2 micro, there's a this T2 medium, right? T2 medium is what we just passed it now. If you can see here, just here. But because my screen is enlarged, that's why I can see it all at the moment. So when you click on the one you want, say for today we're using T2 micro, it will tell you this T2 micro belongs to the family T2. It has just one vCPU. vCPU is your compute power and 1 gig RAM. You remember I said it gives a balance of compute and memory. It gives a balance of compute and memory. So this is giving you one vCPU, 1 gig RAM, which means that if your application needs more than this, please and please don't use it. That's what it's basically telling you. This is all you get on this type of instance family, right? And it tells you that, oh, it is free tier eligible, which means if you are within that confines of free tier of AWS, you're not going to be paying anything if you use this particular instance type. So today, let's say we're going with the T2 micro, and to also tell you how much it will cost you. So if it's on a Linux AMI that I chose, I'm going to be paying $0.0126 per hour. If it's a Windows one that I chose, I'm going to be paying 0.0172 USD per hour, right? If it's a Red Hat operating system that I chose, this is going to be the cost. So those are some of the things that you also note. But our AMI is a Linux AMI. If you notice it, it's a Linux AMI. So assuming we're paying for it, we're going to just be paying 0.0126 per hour. Now the next one is this keep here. Now I didn't want to create, but for us to get an understanding, right? We are going to create one tonight. So I don't have anyone already created. So you also see that there's an option to proceed without a keep here. So you're allowed to proceed without a keep here, right? But then it's good. But let's create one. So when you want to create, you give it a name. So let's say liter keep here represented by KP, right? Liter keep here represented by KP. Okay, hope we're all still following. So you choose the instance, the type of keep here. This is the most commonly used. This is what you are most likely going to be using, right? So choose the RSA is a dot spam. Just choose this, except you are using a putty. Putty is a one of the interfaces that you can use to communicate, right? I'm going to be using an open SSH, so I'm using dot spam. Again, don't worry your head too much about this. Slow and steady, right? So those are the two things you need to put: the name, the type, the file format you want. So I click on create keep here. Now if you note, something just downloaded here. So it has downloaded that um the keep here as a document on my system. I'm the only one that have it. So we'll get back there. I'll go and open it later to show you what it looks like, what is inside of it, right? So come to network settings, which is another thing that you have to select. So under your network settings is where you're going to select the VPC type that you want, how many subnets This is already the default one, but for the sake of learning tonight, let's create our own. Let's create a new one. Oh, it's going to take a lot of time. I will have to start going to VPC. Should we do that tonight? Do we want to see that? Yes, no, yes, no. Should we go and create our own VPC or just use the default? No. Okay. All right. So let's use the default. The first answer that came in was no. Let's use the default. Okay. All right. So we're going to just stick to the default for today. So here, when you create an AWS account, it comes with a default VPC. So this default VPC has been created, right? Here is where you choose your subnet. Remember, I said the VPC is created in the region, while the subnet are created in the availability zone. Now, this VPC is going to be sitting in Ireland region because that's where we are. These are the availability zones that are in Ireland. There's EU West 1C, there's EU West 1B, and there's EU West 1A. So I can decide whichever one I want my instance to be sitting on. So let's just say I want it to be in 1B, right? So it's going to launch this in EU West 1B. Now, EU West 1B, the availability zone is a physical location as well within Ireland where a data center is. So within that Ireland, their availability zones are also separate physical locations where those data centers are going to be sitting in. So let's say, for example, if Nigeria was a region, right, you can have an availability zone in maybe Lagos. So which means that there's going to be a data center that is physically present in Lagos, right? And maybe we can have another availability zone in Abuja. So there's going to be another data center physically present in Abuja. So when you come on the console, you're going to probably see Nigeria region, right? Lagos, Nigeria West 1, which is maybe Lagos, and then Nigeria East 2 or something, right? Whatever naming convention they decide to give to it. But that's what it basically means. Now, auto assign public IP. Now, this public IP is what, if you don't have a public IP address, you'll not be able to access it over the internet. So, a public IP address is what is assigned to your instance. So that in case you want to check, maybe you put an application on it and you want to access it from the internet, you will use that IP address to access it, right? So, we're going to use that, we're going to enable it. Then, security group. Remember, I said security group is what allows or denies access to your instance. This one we're going to create. Sorry, we're going to create. I mean, so let's name it Lita Security Group, denoted as SG. You can just you have to give a description. So let's say um, allows traffic to and from Lita test server, right? So that's the description that we're putting there, that it allows, it's going to control traffic, or it's changes to control traffic instead of allow, because it's not going to be allowing everything. So control traffic. All right. So these are some of the rules, right? So SSH basically means this rule now is me saying I want to access my EC2 instance not from the AWS console, maybe from like a command line interface, right? Or from my, that's where I would need that key pair that we downloaded the other time. If I don't enable this, I will not be able to access this instance, even though I have a key pair. I'll not even be able to access it at all before it will even request for a key pair. So we're enabling this, and so you put the type. There are different type. You can do all TCP, you can do all traffic. All traffic means you should accept any type of traffic, basically, right? So take note that this is the inbound rule. Remember, this is what you allow into that instance. So we're allowing SSH, right, from anywhere, which means from anywhere, as long as that type of traffic is um SSH kind of traffic, right? You allow it from whatever, either it's coming from my system or it's coming from US or it's coming from anywhere, allow it, right? So this is already allowed. We're going to add one more. Now, this one we're going to say you should allow internet traffic. Now, internet traffic is usually denoted by HTTP or HTTPS. HTTPS is when you have like a security credential attached to it. So we're working with just HTTP for tonight because we don't have any security credentials we want to upload to it yet. So HTTP, where is the traffic going to be coming from? Let's say anywhere as well for tonight. Please, this is not usually advisable for production workload, right? Especially if you have things that are going to have sensitive data on them. So we've created our inbound rule. The two rules says allow SSH kind of traffic from anywhere into the instance. The second one says allow HTTP kind of traffic, right, from anywhere into the instance. That those are the two inbound rule. You can also add an outbound rule, right? But by default, AWS allows traffic to go out of the instance by default. It allows it to go out, but by default, it denies every traffic into the instance except you configure it to now begin to accept traffic. So if we had not configured this, it would have blocked every kind of traffic by default. But for outbound, it's by default it allows traffic to go out of the instance, just like the ushers that we said, right? So we're leaving all of this ones. We don't need all these complicated ones for now. Now, the last part that you're going to be choosing is storage, the hard disk, right? The hard disk is going to be attached to this your computer, this your virtual computer. How many gig storage do you want that hard disk? Just like you're buying your memory card, how many gig memory card do you want to attach to this instance? Let's work with 8 gig. 8 gig is fine. We're not doing plenty things tonight. Now, for the sake of, I want us to be able to see when we finally launch this instance, to see a physical evidence, right? I'm going to add something. It's called the user data. Now, the user data is something that you add. Let's say maybe you are going to be putting a particular application on this instance, and it needs a Python library to run, it needs a Panda library to run, it needs some of these things. Whatever configuration that you think, whenever you start this instance, it should start with that instance. That's what you put in this place. So I already wrote out a code, right? So what the code is saying is that start up this instance. When you start it, when I go to that instance, I want to be able to say congratulations, you launched your first liter instance or something, right? So I'll just go and copy that code from where I wrote it, right? So basically this code is saying update fail for update this instance, right? Update it, start it. Please don't bother yourself if you don't know coding, right? This is what we're focused on. This is what is going to write on the front end. When you go to the website of the link, the IP address of this instance is going to show you this. We don't have an application that I want to put on it yet, but so that you can have a physical evidence, right? That's why I'm doing this. So I'm going to add this here, and then it's going to show you a summary of your instance. So summary is that you are launching just one instance, so you can decide to launch two at the same time if it's the same configurations you want. This is the AMI that I chose, Amazon Linux 2 AMI. This is the instance type that I choose. I used a new security group, right? This is the storage that I attached to it, the memory card in quotes that I attached to it. Then you click on launch instance. So we're going to give it a few minutes to launch. All right, so says successfully initiated the instance, right? So we're going to come to our instances here. Just click on instance. So refresh here. So when you refresh, you can see that before we didn't have anything here. At that first time I wanted to launch the instance, there was nothing here. So now we have one instance here. And how do you know that is the correct instance? You named it. This was the name of the instance that we created, right? This was the instance type that we chose. So currently is in a running state, which means it's already running. But I remember the last time I showed us, you need to also check for this. It's going to do a status check that everything is correct, check that everything you have put on it is going to work fine. You have put in the right things in place. So that is what it's doing here, is initializing it. And until it gives you a 2/2 mark, you cannot do anything on this instance. You will not be able to do anything, right? So let's wait while it's initializing. While it's doing that, you can always click here. If you check the checkbox that is beside the name of the instance, it will open up and you can see more details about that instance. Let me interact with it. All right. So I checked that one, right? So you see details here. It's going to tell you the instance ID, the public IP address. So when we want to check the that stuff that I put there that I said congratulations, I want to check it now. This is the IP address that we're going to use. Every instance also has a private IP address. They'll have a, because we said we wanted a public IP address, so it's going to have a public IP address and a private IP address. Even if you did not request for any IP address, to automatically view a private IP address, because this is what it will need to communicate in-house, right? So the host name type, the instance type, the VPC that it is sitting in, all of those things, the subnet that it is sitting in, the subnet ID, right? You can also check for the status and the alarm of it. Currently it is still initializing, so you're going to have this. If you set up an alarm, maybe you say, okay, I want you to always notify me when I have used or I'm at 80% utilization. You can set up an alarm. So whenever it's at 80%, to always notify that your instance has gotten to 80% utilization. So you know whether you want to increase it or you want to stop it or whatever it is that you want to do, but to notify you if you configure it. Monitoring. So um what controls the alarms, right, is from here. So you check your monitoring. So you see different things, your CPU utilization, the network, amount of network that is coming in, the amount of network that is going out. Those are all the things that you can check from here, right? Those are all the things that you can check from here. Presently, we are not doing anything, so there's no data that is available on that yet. Security, this is where you find a security group that you attach to it. So we attach Lita security group. You can check the inbound rule. This is the inbound rule. Our rule says that we should do what? We should allow port 80 is the HTTP one that we attach. Port 22 is for SSH. Please don't fret. These are things you learn over time. It's not things that you cram. They're things that you learn over time. And when we said you should accept these ports, right? Any of this type of traffic from anywhere. This 0.00.0.0/0, it's what is representing anywhere. So anytime you see the 0.0.0.0/0, it means anywhere. It means accept whatever kind of traffic is here from anywhere. I can limit it and say I only want it from my laptop. So I'll just go and get the IP address of my laptop and put it there, right? So that's where we are at now. Let's see if our instance has finished initializing. Just refresh here. Okay, so you see it's now in 2/2 check, right? So which means that we can now check it. So let's see what we put on it on the internet. So we'll come here, we'll copy this, right? Copy this and then paste it in your browser and enter. So can you see? Congratulations, you successfully created an instance for later. Now remember, this is not what you see every time. This is what I put on it too, as if we're putting an application, right? So if this was not working fine, if maybe we did not allow HTTPS, it's not going to be successful. Let's try it out, right? So I've seen congratulations, you successfully created an instance for later, which means our instance is working perfectly well, right? So let's come back here. Where's that? Is the security group? So let's come here now. Let's go and remove this particular rule that says allow HTTPS. This is so that we can see. So I'm coming here. I'll come to the security group. I'm going to go and edit it. And what I will do is this HTTP one, which is what I said controls internet traffic, right? This stands for internet traffic. I'm going to delete it. So I've deleted it, right? Then I'll go back to my EC2 instance. All right, so now let's go and check if that IP address will still work now, right? Sorry, give me 1 minute. Let me refresh this. Oh yeah, I just remembered. So I allowed outbound. Give me 1 minute. Where's that my security group again? Oh, she's 12 minutes to 9. Please, you can start dropping your questions, or so we'll just check them out. Right, so this is where you can also find your security group. There's a default one that is usually created, but we created a new one, right? To permissions entry, let's go and edit this. Sorry. Allow from anywhere. Okay. All right. So I'm going to post this link now on your end as well. Sorry, this is a lot, Abby. So you can click on this link and check if you can all access. If you're going to get the congratulations you successfully created, I just pasted a link on the chat now, the YouTube chat. So check if you can access it. Just quickly paste it in your browser and check if you can access it. All right, for installer says I should explain the instance type. Okay, I'll do that. So can we all confirm that you are seeing this? Congratulations, you successfully created an instance type. This link, the 54.1, okay, 54.1 is so it's not your regular link that you're expecting. In your browser, just type 54.195, 54.195, Are we typing? I already posted it though, but I think not everybody, because we're not used to that kind of a link. 54.195.146. Yes, thank you very much, Damilola. So that's just put that particular number code on your browser. Okay, not accessible. Okay. Eunice, what's the error you got? All right, so I am in the fine. So Eunice, are you sure you put the code correctly? All right. So that's a proof that our instance is up and running. All right. Okay. So Eunice. Okay. So let's just. I'm not going to stop it for now so that we can all check through, right? But later on, there are different ways I can come back here to come and um either terminate the instance. So I think I explained the last time as well that I can just come back here. When you click on that particular instance, please always check that is the instance you want to stop or you want to terminate that you have clicked on. You come to instance state. You're going to see an option to stop the instance, to reboot the instance, or to terminate the instance. All these things are basically what it sounds like. Stop means you're pausing it for a while. It's like you're just shutting down your system for a while, right? Or you're making it to sleep. Making it to sleep. When you start it back, everything that you have on your system will still be there, right? All of the pages, all of the tabs that you have opened, all of them would still be there running. That's what happens when you stop. But when you stop, your money is no longer counting as well if you're on the on-demand pricing, right? So until you restart it back before it starts counting. Reboot is, of course, like you're restarting your system. That's basically what reboot also stands for. Now, terminate is delete, and terminate is permanent. Once you terminate it, you have terminated. You cannot restart it. You cannot bring it up again. You have to go and create or launch another one, basically. So for tonight, I'm not going to stop the instance yet. I'll give it for like 30 minutes so that those that have not yet checked can check it out, basically, and then we'll put a stop to that. All right, so that brings us to the end of our demo for tonight. So back to the questions of um the different type of instance, right? The instance type. That's one question that I've seen, right? So what I was saying is, let me go back to share my slide. Give me 1 minute. Let me stop sharing this one. I have just 6 more minutes to end this class. So let me go back and share my slide. Okay. So let's go back to the beginning. So I was saying that the instance type is what determines the ratio of computing power to memory that you have. And that is determined by the kind of application that you want to put on the your EC2 instance. Let's say, for example, now the only thing I have put on the instance that we started, right? The only thing that I have put there is congratulations. It's not consuming anything at the moment. It's not consuming a lot. It's consuming close to nothing. So it will not make sense that I will now go and use an instance type that has a 4 vCPU or something. So depending on the kind of application that you want to put on that instance is what is going to determine the kind of um, instance that you are going to select. And I said there are different types. There's compute optimized, there's general purpose, there's memory optimized, there's storage optimized. Now, general purpose is the application I want to put on these things. It needs a balance of all of it. It needs a balance of the vCPU and the memory, right? That's the RAM. That's your the RAM, the memory that comes with your computer in quotes, right? Not the hard disk now. It needs a balance of it. And I said your vCPU, which is your computing power, is what determines how fast your process will go, how fast the operations that are happening on your system are going to go, right? The quickness of it, basically. When you say, oh, I'm trying to load something and the thing is taking time to load, it's probably like your computing power of that system is small. If you notice, some systems, when you put it on, within 5 seconds they have come on, they have HP have finished running, they have shown everything you have on your desktop. There are some, it will run for like 30 minutes. It means the computing power is what is small or is already almost full, right? So if the application that I want to run is something that I know that is going to be requiring a lot of compute power, which means it will not need a lot of memory because I will not be saving a lot of things on it. But it's going to be the things I want to be doing on it is going to require continuous, workings. It's going to require a lot of power, a lot of computing power to do. So I'm going to go for an EC2 instance that has more compute power than memory, which is the compute optimized, which means that particular instance has been optimized to have more compute. So for general purpose, something that is balanced, you can have a 2 vCPU, that's 2 vCPU is your 2 computing power, right? And then 2 memory, 2 gig memory is balanced. But for a compute optimized, you can have a 4 vCPU and 2 gig RAM, which means that that particular instance is favoring your vCPU more, is favoring compute more than memory. For you to go and choose that kind of an instance type, you will have to go and check the kind of things you want to put on the instance on top of that server, on top of that your virtual computer. Is this thing going to need more vCPU or more memory? If it's going to need more memory, then you go for a memory optimized. For a memory optimized, you can see a 2 vCPU 8 gig RAM. If you are seeing a 2 vCPU 8 gig RAM, that simply means that whatever it is you are going to be putting on that instance needs more memory. You are going to be saving things there more than things that will be needing power to work, right? Say for example, if I'm storing stuff on my system now, it does not necessarily need power, right? It does not necessarily need computing power, but it's going to need the space that is going to be storing those stuffs. Do you get? So what I want to put on my system is what is going to determine the kind of instance that I'm going to select. Does it need more compute power or does it need more memory? That's basically the two things that matter. Does it need more compute power or does it need more memory? So hope that is understood now. Do you get what I mean by the compute instance type? That those are what it controls basically. Those are what it controls. Hope that is clear now. For those that have gotten the congratulation page, there's nothing for you to do again. Don't worry, there's no application on it. We did not go and put a application on it. We just put it there so that you can see it as a physical evidence that the instance is running fine. Right? So it's just a physical evidence that the instance is running fine. If we didn't put that there, your instance will just be there. If you click on it, it will just show a blank page. You'll not see anything that is going on there. Right. So um okay, so I'm glad that everyone now gets a better understanding of the instance type. All right, it's 9 o'clock on dot. Thank you all very, very much for tonight. I'll put the address on the Telegram chat so that you can, for those that have said they've not seen it, I'll put it on the Telegram chat. Just check it, and by 9:30, I'll go and terminate that instance so that it will not incur any cost. All right. So thank you all very much. Please be on the lookout for tomorrow, Wednesday's class. It's going to be an interesting time with Mr. Moses. We'll be looking at scaling and all of those things, right? So thank you all so much. It's nice being here. It's a privilege. to talk and to teach. And I pray that you've gotten something, no matter how little you've gotten something tonight. And again, don't feel discouraged at any point. Feel free to reach out. Feel free to send a DM. We're here. We're here to go on this journey together. All right. So this slide will be sent, and with addition to the slide, you will get additional resources, things that you can go and read up on your own as well. All right. Have a wonderful night, everyone. Thank you very much. Bye.
Have you ever wondered how your favorite apps work their magic without slowing down your phones? Or how do businesses store massive amounts of data without filling up the entire room? The answer is in the cloud. Hi, my name is Yesterday. Imagine renting computer power, storage, and software from the internet instead of buying and maintaining your hardware. That's cloud computing. It's like having a super-powered computer at your fingertips whenever you need it. Why is cloud computing such a big deal? Well, it's like having a genie in a bottle. You get to focus on your business while the cloud handles the tech stuff. Plus, it saves you money, improves flexibility, and scales with your need. The cloud is growing faster than a fluffy cloud, and that means amazing career opportunities from cloud architects and engineers to security experts and data analysts. The cloud world is buzzing with possibilities. Ready to dive into the cloud? Our course will take you on an exciting journey. You will learn about different cloud models, how to design and deploy cloud applications, and master essential cloud platforms like AWS, Azure, and GCP. Are you ready to unlock the power of the cloud? Join our course and become a cloud expert. Subscribe to this YouTube channel and follow us on all our social media platforms.